Ladies and gentlemen, welcome to the 2025 Calculable Championship game between the Maria Creel Pumas and the College Board Acorns.
The Acorns are looking for a historic three-peat victory today, while the Pumas are looking at their first championship appearance in 10 years.
The Acorns with their first play. Jane Mahomes throws it long. Deanne Jackson makes the catch. Touchdown, Acorns.
Wow, what a play from the Acorns. Chamberlain Mahomes has been a strict rid of this whole season, delivers yet again with another blow against the Pumas.
But now it's turn for the Pumas. They've been trained to marinate in as many points as possible for years now. Can they come back with a quick play here?
Hand off to Shengkai to run the ball. He's got space. Oh, he fumbles the ball. Possession back to the Acorns.
That was a great tackle from Chainroll Mahomes. I'm surprised Shengkai Huang hasn't been sent to the L'Hopital yet after that fall.
Acorns are driving deep into Puma territory. It's a pump fake. The defender can't catch him. Touchdown, Acorns!
Score is 14-0 Acorns. Now the Pumas are at the 30-yard line.
It's looking like a lousy throw from quarterback Nathan Kiehl. And here comes Deanne Jackson with the interception. It's true that no one knows where his limits lie.
Yes, indeed. His end zone behavior is unpredictable.
It's 21-0 Acorns. The Pumas are going to need something before halftime if they want to stay in this game.
Oh no, what should I do? I should solve the first question. Question 5a. There was a point on the curve near 2, 4 with x-coordinate of 3. Use the line tangent of the curve at 2, 4 to approximate the y-coordinate of this point. What we can do is use our derivative of the equation that has been provided to solve for the slope of the tangent line. We can do this by plugging in the values of x and y provided to us of 2 and 4. Your answer for the slope should come out to negative 4/19. This will earn you the first point. After this, what you can do is you need to solve for the y value at the point of x equals 3. So what you need to do with this is using the slope that you just solved for and the coordinate values you were originally given, you need to create a equation for the tangent line. Then, using this equation for the tangent line, you can solve for your y value. This solution for your y value should give you your second point. To get the first point, all you need to do is state at some point that the slope is equal to negative 4/19. You do not need to explicitly solve for the slope of the tangent line. Therefore, the easiest way to get both points would be using the statement of your y is going to be equal to 4 minus the 4/19 times your 3 minus 2, and then solving for that. In this example, they would have earned their first point. This is because they solved correctly for the slope of the tangent line and got negative 4/19. However, they would not have gotten their second point because when solving for their equation, they did not correctly account for their x value and ended up multiplying their negative 4/19 times 3, therefore giving them the wrong answer. In this case, they would have gotten 1 point.
Kiehl is sacked. What a charge from Chamberlain Mahomes. And what has happened with the Pumas at all right now?
That's a serious mistake from Kiehl, and definitely not something you want to see from an experienced quarterback like him.
This concludes the first half, everyone. Coming up, the Calc Time Show by the legendary Ken Derivative Lamar. Stay tuned, we will be right back after this commercial break.
Well, well, well. Look what we have here. We're losing 21-0, boys. You got anything to say?
Well, College Board's the best team in the league.
Well, that's kind of true. What about you?
Maybe we should have a plan.
What plan? We're losing 21-0.
Coach, I have a plan. I found the other team's playbook. With this, we can win the Calcula Bowl.
Is that the AP Calculus? AB 2024 free response questions? Question number 5?
Yes, it is. And with this, we can come back and win this game.
But how do we solve it?
I don't know. Let's tune into the Calc Time show to find out.
I have it on here.
Coming up, the Calc Time Show by the legendary Ken Derivative Lamar.
Wop, bro, plug him in. Wop, horizontal line. Why are you trying to find the slope? Ain't you tired? You're trying to visualize it, it's probably a 0. They're not like calc.
No.
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 I understand it now.
Part B asks, is the horizontal line y equals 1 tangent to the curve? Give a reason for your answer. Recall that because the horizontal line y equals 1 is horizontal, it has a slope of 0. Thus, when we are trying to find if it is tangent to the curve defined by the equation, the derivative at the tangent point must be the same. So, we need to find when the slope of the tangent line, which is the derivative, is equal to 0, since the line is horizontal. To do this, set the equation for the derivative equal to 0, then solve for the x value. We then get an x value of 0, meaning that at the point 0, 1, the line tangent to the curve would have a slope of 0. Now, we need to check if this point lies on the curve. By plugging in the x value of 0 from the tangent points, we can see that this point is not on the curve. Therefore, the horizontal line, y equals 1, is not tangent to the curve. An alternate solution is also possible. In this alternate solution, we first find when the line intersects the curve, and if the slope at that point matches the slope of our line given, which is 0, then the line is horizontal. So for this alternate solution, the y value of 1 from the horizontal line given is plugged into the equation for the curve to receive an answer of x equals plus or minus the square root of 43. Then they will take the derivative of the square root of 43, which is equal to plus or minus 2 times the square root of 43 over 7, which is not equal to 0, which is a slope for y equals 1 because it is a horizontal line. To earn the first point, the student must set dy dx equal to 0. Acceptable answers also include setting negative 2x equals 0, or x equals 0, or identifying the point 0, 1. To earn the second point, the student must provide a reason why the line y equals 1 is not tangent to the curve. Simply stating that the point is not on the curve with no reasoning is not sufficient to earn this point. To earn the first point for this alternate solution, students must use y equals 1 and plug it into the equation for the first curve, resulting in x squared plus 3y plus 2y squared equals 48. To earn the second point, the student must provide a reason why the line y equals 1 is not tangent to the curve, and again, simply stating that the point is not on the curve with no reasoning is not enough to earn this point. A response that fails to consider that x can equal positive and negative square root of 43 will not earn the second point. Here is a student sample for this problem. The student took the second approach, plugged in y equals 1 to the equation of the curve, earning the first point. However, the response did not earn the second point because it failed to consider both the positive and negative square root of 43. This student earned just 1 point out of 2. Here is another student sample that earned all the available points for this problem. The student earned the first point by setting the equation for the derivative of the curve equal to 0. Then they earned the second point with the correct reasoning, demonstrating that the point 0, 1 does not lie on the curve. The most common mistakes are forgetting to consider both the positive and negative square root of 43, and failure to include adequate mathematical reasoning in the answer. The key concepts covered in this problem are horizontal tangents, tangent line to a curve, and differentiation.
This part of the problem is actually really simple. So, for the slope of an equation to be directly vertical, it would have to have, since slope is rise over run, the numerator would either have to be infinite, which is impossible with set inputs, or the denominator would have to be 0. And since we already have the equation for the slope, we can simply plug in the points at that time to see what we get. So if we take dy dx, you see that it equals negative 2x over 3 plus 4y, which equals, what is that? Negative 2, negative 2 root 48 over 3 plus 4 times 0. This comes out to negative 2 root 48 over 3. And very simply, since neither 3 and since 3, which is the denominator, does not equal 0, this function cannot have a vertical slope at this point. And this is because its denominator is defined. Thank you so much.
And ladies and gentlemen, welcome back to the second half of the calculable between the Pumas.
Pumas on me, Pumas on 3. 1, 2, 3,
Pumas! Score of 21-0.
Alex Yoon from the Pumas gets the ball, throws it far. Shengkai Huang is there.
And he's in for the touchdown!
Wow, that was quick. What a comeback from Shengkai Huang from the first half.
Alex Yoon fakes the handover to Shengkai Huang, goes long. Shengkai Huang catches on the line.
The Pumas have a solid chance at a comeback now.
He jukes AP Kelsey for the touchdown. The Pumas are tied with the Acorns.
Now it's 21-21.
Okay, let's take a look at part D.
Last play of the
that's
game,
gonna tell
it's a
us the
field goal
trajectory of the
opportunity
ball,
for the
right?
Pumas.
Yes.
If they make this, they win.
Number 5, part D. For time t is greater than or equal to 0, a particle is moving along another curve defined by the equation y cubed plus 2xy equals 24. At the instant the particle is at the point 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. At that instant, what is the rate of the change of the x-coordinate of the particle's position with respect to time? This sounds like a related rates question, and for all related rates questions, we want to write the given equation and implicitly differentiate it. So we write the equation y cubed plus 2xy equals 24. Differentiating it, we get 3y squared times dy dt, remembering to apply the chain rule since we are differentiating with respect to t, not x or y. Then we use the product rule to get 2x dt times y plus 2 times x times dy dt. And all of this equals the right side of 0 since differentiating a constant gives us 0. Now we get an equation in terms of x, y, dx dt, and dy dt. The problem gives us 3 of these values. From the coordinates 4, 2, we get x equals 4 and y equals 2. Also from the fact that the y-coordinate is decreasing at a rate of 2 units per second, we get dy dt equals negative 2. The question is asking us to find the rate of change of the x-coordinate, which is dx dt. Plugging x, y, and dy dt in, we get this equation. And solving for dx dt, we get dx dt equals 10. 1 point was earned for an attempt to implicitly differentiate the given equation as long as there is 1 mistake or less. For example, differentiating with respect to x, not t, will still earn this point. 1 point was earned for the correct equation after differentiating, given here. 1 point is earned for declaring or substituting dy dt equals plus or minus 2. If you interpret the decreasing rate as a negative rate, then you would use dy dt equals negative 2. And if you interpret it as a positive rate, then you would use dy dt equals 2. Regardless of which value you use, the final answer for dx dt is the same. This point is not earned if both the plus 2 and negative 2 values are used in the same equation. Finally, 1 more point is awarded for the correct answer of dx dt equals 10. Note that this point cannot be earned without earning the previous 3 points. This means that you have to get the correct answer with no mistakes to get this 4th point. For example, this response earned the first point by implicitly differentiating the equation, but not the second point because they differentiated with respect to t. It does not earn the third point for using dy dt equals plus or minus 2, and does not earn the 4th point because it didn't earn the first 3 points.
We got it now.
Let's go.
Yeah, let's go.
Alex Yoon kicks it.
Field goal!
It's in! The Pumas win the 2025 Nippers for the first time in 10 years. Congratulations to the Pumas.
We're going to Disneyland!
Put it on that beat, go.